Hey everyone, Geek37 back with another video. This is part 29 in my Exploring the Heptagonal Triangle series, and I'm going to explore an analog version of a problem that I did a few videos back, a couple of videos back actually. Namely, it's the analog to b to the fourth over a to the fourth plus c to the fourth over b to the fourth plus a to the fourth over c to the fourth. This time we've reversed them. It's a to the fourth over b to the fourth plus b to the fourth over c to the fourth plus c to the fourth over a to the fourth. Now I'm going to solve this like I solved that problem a couple of videos ago. I'm going to use the identity that is down below the heptagonal triangle here. And here is how it will work out. I'm going to start off by writing a squared over b squared plus b squared over c squared plus c squared over a squared. And that itself will be quantity squared. And then I'm going to write the identity from above, the equation from above on the right side of that equal sign. And then I'm going to add 2 times the quantity, and I believe I have enough space to do it this time. So I'll be writing it like this. It will be a squared over c squared, a over b squared times b squared over c squared. So I'm just multiplying a squared over b squared times b squared over c squared because those are the first two. And that the second part of in the parenthesis here is multiplying the last two ratios. So b squared over c squared times c squared over a squared. And then plus it's going to be the last one times the first one, or vice versa. Multiplying won't change the, switching the terms in a multiplication problem will not change the answer. So here's what will happen. We have a number of cancellations. So the b squareds will cancel, the c squareds will cancel, and the a squareds will cancel inside that parenthesis. I'm going to go down here, rewrite this as a squared over b squared plus b squared over c squared plus c squared over a squared, all quantity squared, plus the part we're looking for, a to the fourth over b to the fourth plus b to the fourth over c to the fourth plus c to the fourth over a to the fourth plus 2, and here's what we have left inside, a squared over c squared plus b squared over a squared plus c squared over b squared. So let's highlight this part here. I proved this particular one that I'm marking in yellow a number of videos back in the series, and it matches over here with the set of parentheses on the left side of the equation. And the part in parentheses on the right side here, I'll mark this in orange, that matches with the equation down below here that equals 5. I also proved that a number of videos back in this series. So let's replace those sums of squared ratios with our values. So where the yellow part is, I'm going to replace that with 6. So it's 6 squared plus a to the fourth over b to the fourth plus b to the fourth over c to the fourth plus c to the fourth over a to the fourth plus 2. And where the orange part is, we can replace that with the number 5. Let's simplify this. 6 squared is 36. A to the fourth plus b over b to the fourth plus b to the fourth over c to the fourth plus c to the fourth over a to the fourth plus 2 times 5, which is 10. Subtract 10 from both sides, and we get the answer of 26. So the sum of those fourth power ratios will equal 26. And what I find quite fascinating about this is exactly twice the amount of its analog version, b to the fourth plus a to the fourth plus c to the fourth over b to the fourth plus a to the fourth over c to the fourth, because 13 times 2 is 26. I find that quite fascinating. The reason I decided to do this calculation is because it will appear in a problem that I will do later in this series, and I just realized that solving that problem is going to be a lot easier than the way I had planned on solving it before, because I have this particular answer to these sum of these fourth power ratios. So, all right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.